Good morning, everyone. So we're continuing our lesson, which is the Newton's laws of motion, and today we're going to be talking about speed. We took speed before. Speed is basically, we took it in the lesson before. You know it. It's a measure of the distance an object moves in amount of time. Because remember when we said speed equals to distance over time, so it's the distance in the amount of time. Okay. So it's how fast you're going. That's in general, speed is how fast you're going. And the unit of measurement of speed is meter per second or kilometer per hour. You know this. We've already taken that before. That's just revision. Now, we're going to learn how to calculate average speed. We already know this. Speed is equals to distance over time. You take it before. So when calculating average speed of an object, you need to know the distance traveled of an object and the time. Here they're using v because they're talking about velocity, because it's also like, velocity has a vector, like how fast you're going, but in what direction. So average speed would be distance over time. We already know this. But here we're going to calculate it in a different way. We're going to be sort of using an equation, okay, using tables like this to be able to calculate speed over time. Like if I ask you here to calculate speed, okay, and you know that speed equals to distance over time, okay, and I said please calculate speed at distance, because we have this table here. I calculate speed at distance 100, okay. So you have d equals to 100, and you see the unit of measurement is kilometer. Okay, so how am I going to get the time? You're going to have to use this table. So you go ahead distance, because the time is right here and it's in hours. So you go down here and you see, so in 100, time is equal to 1 hour. Okay, so speed would be equal to 100 divided by 1. It's 100 kilometer per hour. Okay, and this is the train, because it's the red one. The car is different. The car is the blue line, you see. Let's see here. So here the equation, it says the equation is on the second page. Here they ask you, use the graph to determine the average speed of a car for the first hour of the trip and for the entire 4-hour period. The total distance traveled each time period can be read from the blue line on the graph to estimate the distance. So we're talking about the blue line on the graph. The car is the blue line. So I'm going to go back here and I'm going to delete all of that. And they said that they want to calculate the speed, average speed in 1 hour of the car. So you go here, okay, and you check 1 hour is here. So we go up. So the blue line stops here, and then you go there. So if the time is 1 hour, t is 1 hour, distance is going to be like, it's a bit less than 100, so it's going to be 80. They already did it, and the time is 1 hour. 80 kilometers, the time is 1 hour. You'll be able to get speed equals to, like here, distance over time. So it's 80 divided by 1, so it's 80 kilometers per hour. Now they said average speed for 4 hours. Let's get the 4 hours. Erase this. Go over here. Okay, so I want to go over to the hour number 4, because they want in 4 hours, and this is the car, so I have to go up to the blue line over here, and then I'm gonna have to go this way. So I'm gonna have to say it's like almost 380, because it's 380. So I'm guessing in the time here was 4 hours, and the distance is 380. So it's distance over time, so it's 380 divided by 4, and then you get the number. Okay? So this is how you calculate average speed. In the other lesson, I would give you the time and the distance, and I tell you calculate speed. In this lesson, I'm going to give you a graph like this, and I'm going to tell you this is time and distance, and then I'm going to give you either time or distance, and you're going to have to get the other one. So if I give you time, you're going to have to go up with the chart and get the distance. If I give you distance, you have to go down with the chart and get the time. Okay? You see what I mean? So the given is going to change. Velocity is the object's quantity described speed with a direction. You already know this, that the velocity is speed with a direction. That's just repetition. Resultant velocity is the velocity that results, like for example, the train is moving 45 meter per second east. This man is moving also 1 meter per second east. So his speed plus this speed, resultant speed would be 46 meter per second, because the speed of the train plus his speed, because he's moving in the same direction. For example, the lady here is moving in the opposite direction. She's moving 1 meter west, and the train is moving 45 meter east. So it would be 45 minus 1, because she's moving in the other direction. It would be 44. That's the resultant velocity. Okay, you can also calculate it if you have something like this. We're going to take acceleration tomorrow. That's all you had to know today.